we had determined that equal volumes of gas at the same temperature and pressure and let's see, do you guys remember anything about what is true about equal volumes of gas at the same temperature and pressure? Tell your partner. What do we know? Equal volumes of gas at the same temperature and pressure. Not the same volume because they are the same volume. They contain the same number of molecules. Whose hypothesis is that? That is Avogadro's hypothesis. Not that that really matters. It's more important that you know the concept than that you know that it is Avogadro's hypothesis, but we'll put it up there anyway. I'm not going to test you. I'm not going to be like, whose hypothesis was this? All right, I will want to know that equal volumes of gas at the same temperature and pressure contain the same number of molecules. Now, the magic temperature and pressure that we are going to be using in grade 11 is 0 degrees Celsius and 1 ATM. What does ATM stand for? Atmosphere. That's going to be the pressure and temperature at which we are looking at all of our gases. This is known as standard temperature and pressure. 0 degrees Celsius and 1 atmosphere. And because standard temperature and pressure is very long and difficult to write, we abbreviate it as STP. At STP, 1 mole of an ideal gas, don't worry about the word ideal, that's more for my 11 enriched class. 1 mole of a gas, we can just say of a gas, occupies 22.4 liters of volume. So, how can you remember 22.4 is the number? 2 plus 2 equals 4. Yes? And is it 22.4 moles per liter, or is it 22.4 liters per mole? Liters per mole, because remember the 1 goes with the mole. So not that one. The only time you don't put the 1 with the mole is when you have molarity. Do we remember that? Okay, good stuff. Volume per mole. What do we call the volume per mole? Molar volume. So the volume per mole is called the molar volume. Okay, and so we now have ourselves another conversion factor, okay, which is the molar volume of a gas at STP. How many conversion factors do we have now related to the mole? Yesterday we had 7. Yeah, yesterday we had 6, so today we have 7. Okay, because we've added this one on. And while we're here, I would like you to get yourself a piece of paper and see if you can write down all of these 7 conversion factors. And I think this is it. This is it for conversion factors for the mole unit. Okay? It's okay. I didn't worry about this one. It's so small. Whatever. And if you're not writing, just remember, you're not remembering either. And if you're not remembering now, then chances of you remembering on the test are lower. Gesundheit. And if you're having trouble, here are the first initials of things. So many M's, right? What does PR stand for? Particle ratio. What does A stand for? Avogadro's number. What does MM stand for? Molar mass. What does MR stand for? Mole ratio. What is mole ratio the same as? These two are the same. Okay, what does M stand for? Molarity. What does D stand for? Density. And what does MV stand for? Molar volume of gas. Molar volume. And you're absolutely right. We should put of a gas. Very good. All right. Things to pay attention to is in molarity. This is for solutions. Only. And molar volume is used for gases only. All the rest of them, it doesn't matter. Okay? Ooh, jumping around there. There we go. Now, those are our 7 conversion factors. We also have 3 divisions. See if you can write them. Do we have 3? Yes, we do. Yes? Yes. Write down your 3 divisions if you've not already done so. And if you're having trouble, there's your first one. What does D stand for? Density. And the third one is the Okay, so I feel like you guys are getting pretty good at the conversion factors, knowing them all. Over the weekend, make sure that you are practicing writing out your 7 conversion factors in your 3 divisions, because part of why people may do poorly on the mole unit is because they just don't know what their divisions are or what their conversion factors are. Yes? So make sure that over the weekend you're like writing these out maybe once or twice each day, something like that, so that you just have them in your head, because we will be finishing this unit Monday or Tuesday, okay, because we're almost done at this point. And then I would like to have your test the following week, because I want you to have like a good review period. Do you know what I mean? We'll start our other unit in the meantime, though. Okay? Yes. Right. So we'll be finishing our unit on Tuesday or Wednesday, okay, of next week. And then we'll have our test the following week. Okay? All right. How do we find molarity? What do we divide by what? Moles divided by liters. Density. What goes on the top? Mass. And what goes on the bottom? Volume. And it doesn't matter what unit you use for volume. It could be liters or milliliters or centimeters cubed. Doesn't matter. And we just learned molar mass yesterday. How do we calculate molar mass of an unknown? Grams divided by moles. Okay, and in the past, I've had students calculate molar volume as well. I've left it out this year just due to time constraints. So, but if you were to calculate molar volume, it would be volume per mole, okay? At any rate, here we go. Those are our 3 divisions. All right, and I will say that the one people most often forget is this one, because they get so used to calculating the molar mass using the periodic table, and that's going to do you for 85 to 90% of the time. There's going to be like one question, right, where it says, what is the molar mass of this unknown gas? And it'll probably give you the number of molecules and the number of grams, and you have to do a conversion. Okay? Alrighty, so that's where we are at today. And this molar volume of a gas is the one we're practicing on today. That is 22.4 liters per 1 mole of gas. So we can use this for some very simple problems. What is the volume in liters? We're back on page 82, I think. Yeah. Page 82. What is the volume in liters of a 2-mole sample of methane? And it doesn't say gas, but if it says at STP, you can assume it's a gas. What does STP stand for again? Tell your partner. It stands for standard something or other. Standard what? T stands for temperature. And P stands for pressure. And what is the standard temperature? 0 degrees Celsius, and standard pressure is 1 atmosphere. You should know those, okay? Okay, so what is the volume in liters of a 2-mole sample of methane at STP? So we want to say, what is the volume in liters? And we're starting with 2.00 moles of methane. What do we want to cancel? We want to cancel moles of CH4, and we want to find liters. This is not a solution, so you will not be using molarity. This is a gas. So what numbers do we use? What number goes with the mole? 1. And what number goes with the liter? 22.4. Are you on your phone, Anthony? No. Okay. Good. Was that a calculator? Okay. Okay, so 2 times 22.4 is 44.8 liters of CH4. Easy peasy, yes? Simple one-step problem. Now, this one, I should have said ethane gas. I need to fix that. Okay, so this example should have said gas at STP. So how many moles of ethane, C2H6, are there in 5.60 liters of ethane, C2H6, of course, at STP? What unit has to go on the bottom? liters, C2H6. What unit goes on the top? Moles, C2H6. And what number goes with the mole? The one goes with the mole, unless it is molarity. The one goes with the mole, unless it is molarity. The one goes with the mole, unless it is molarity. Join me. One goes with the mole, unless it is molarity. The one goes with the mole, unless it is molarity. The one goes with the mole, unless it is molarity. Okay. So what number goes with the liters? 22.4, because 2 plus 2 equals 4. All right, so 5.60 divided by 22.4 equals 0.25 moles C2H6. Bam, bam. Okay? What do you think of my answer? I need to have 3 sig figs, so I need to toss a 0 in there. Even though the calculator spat out just 0.25, I need to have 3 sig figs. Okay, so in this one, I'm not going to give you time to practice right now because this is just too easy. It says, do the odd numbers only. If you are a super converter, you can just do 11 and 12, okay, because those are sort of more challenging. Write the formulas for the compounds, not just the names. Check to see that you're getting the formulas correct. Why am I suggesting you write the formulas? Because you don't want to forget how to write formulas, right? So this is a little review of formula writing while we're at it. Okay, so at any rate, you can do the odd numbers only on this one. If you're a super converter, just do 11 and 12. Be sure to write the formulas. Say, for example, of hydrogen. Tell your partner what is the formula for hydrogen. It is H2. Okay, don't forget your diatomics. Everyone tell me, who are the diatomics? Dr. Brinkelhoff. Any other gas? Any other element? No. Okay, just those 7. Brinkelhoff. All right. We are now going to move on to, where is it? No, I've lost it. Oh, have I just really not printed it out? 5.5b, I've moved it is what I've done. Okay, okay, page 85. Molar mass and density. Tell your partner, how do you find density? Density is the mass over the volume. So in theory, that's like grams over liters. How do you calculate molar mass if it's unknown? We just did this. How do you calculate molar mass of an unknown? Grams per mole. Honestly, it is the formula is just the unit for molar mass. What's the unit for molar mass? Grams over moles. What's the formula for molar mass? Grams over moles. What's the unit for molar mass? Grams over moles. What's the formula for molar mass? Grams over moles. Everybody, what is the unit for molar mass? Grams over moles. What is the formula for molar mass? Grams over moles. Okay. All right, and if you see here, what we've got is we've got grams on the top of density, and we've got grams on the top of molar mass. What we've got on the bottom is we've got liters and we've got moles. So if we're working with gases, do we know how to convert between liters and moles if it is a gas? Tell your partner, do we know, yes or no, how to convert between liters and moles if we have a gas? The answer is yes, we do. And now I would like you to tell your partner the conversion factor for converting between liters and moles of a gas. We would use the molar volume, which is what? 22.4 moles per liter? Is it 22.4 moles per liter, or is it 22.4 liters per mole? This one. Okay, not that one. Okay, so you can convert back and forth between density of a gas and molar mass of a gas. So we now have three ways of calculating molar mass. We can use the molar mass formula if we're given grams and moles or grams and molecules. If you're given the formula, you can just add from the periodic table. And now this one, we can use density and convert it into molar mass, but only if it is a gas. Okay. So find the density in grams. Oh, here we go. Here's the example. Find the density in grams per liter at STP of natural gas, methane. And very often students will look at this question, they'll be like, oh my gosh, I have no idea, what on earth will I do? But you actually do have some numbers. Where could you find some numbers? Yeah? The CH4. What could you find out about CH4 that would give you some numbers? You could find its molar mass. Okay, so find the molar mass. And when you write the unit for this, and you should be writing the unit, you should write it as grams and then over moles rather than like grams per mole, because you want to make sure you've got it structured like this so you can turn it into grams over liters. Okay? So my density is equal to, we don't know how many grams per liter. And we're starting with 16.0 grams per mole. Grams are good. We don't want to do anything with the grams. We want to leave it alone because it's on the top and we want it to stay on the top. We do need to convert between liters and moles. So if we want to get rid of the mole, where do we put it? On the top. So we got moles here and we want to have liters on the bottom. And we know that we're dealing with a gas at STP. So what numbers go in here? Everybody. What goes with the mole? What goes with the liter? Excellent, 22.4. And we get 16 divided by 22.4 equals, and we get 0.7143. And my unit, my moles cancel. What am I left with? Grams over liters. Is that what I wanted? Yes. And am I done? No, what am I missing? Sig figs. How many sig figs do I want? I've got 3 here and I've got 3 here. Don't forget your 0.0 if you've got a 0.0, okay? So this is 0.714 grams per liter, and that's your final answer. Density of an unknown gas is determined in the laboratory and is found to be 4.22 grams per liter. How should I rewrite that? I should rewrite it as grams over liters. What is the molar mass? So I want to know the molar mass. And what's the unit of molar mass? Grams over moles. And I'm starting with 4.22 grams per liter. It is a gas. It is at STP. So I am perfectly capable of using my molar volume. And what do I get? What do I have to cancel here? I need to cancel my liters because I don't want liters. I want moles on the bottom. So where do liters have to go? They have to go on the top. And where do moles have to go? On the bottom. And so we have 1 liter per 22.4 moles. I got one person shaking their head at me. What have I done? Yeah. Yes. But what have I done? Wilfred, before you go, what have I done?
Did something wrong?
Yeah, I did something wrong. What did I do wrong? I got to flip the number. I don't know what that other thing he said was, but that's all we have to do. We have to flip the number. 22.4 liters per 1 mole. Okay, and we get 4.22 times 22.4 equals 94.528, which should round to, then we have got 3 sig figs, and 3 sig figs gives us 94.5, and the units, always check your units at the end and see if they worked out. Grams over moles. My grade 12s, oh my gosh. Grade 12 chemistry, they're like most of the way through grade 12 chemistry, and I've still got people saying things like this. Molarity divided by liters equals moles. I had at least 5 people do that. And I'm like, oh, honey, that is so wrong. What is wrong with what my grade 12s have done? That capital M stands for molarity, which is moles per liter. So we have moles per liter over liters, which is going to be moles over liters squared. And what the heck is that? That is nothing. Okay, so when I tell you check your units, it's because I not only want you to do well in Chemistry 11, but if you're signed up for Chemistry 12, I also want you to do well in Chemistry 12. So check your units at the end and make sure they actually end up giving you what you wanted. Okay? All right, so I think that's all we need for now. We're not going to do dilutions until next week. So you can start doing, where is? Pages 82, 83. Pages 82 to 84. And if you do nothing else, you must do numbers 11 and 12. And if you're finding it more challenging, or if you're having trouble remembering where the 22.4 goes, you should do the odd numbers. Okay? That's number one. Number two, because you've got a 4-day weekend. And guess what I'm doing with my 4-day weekend? I'm marking 55 chemistry 12 tests. And in theory, I'm going to be marking your labs. Woo! So I'm going to share the pain, and I'm going to give you guys some homework because we need to finish this. We need to make sure we get through reactions and stoichiometry before the end of the year. Okay? So, bam. Let's see what else I'm giving you this weekend. You got a half an hour now. Okay, so you might as well get a bunch of it done, and then you'll have much less to do for the weekend. Where is it? Where is it? Pages 85, 86. And then 87, 88, 89, 90. So 87 to 90. Actually, no, let's just do 87 to, oh, no, that's okay. Do the odd numbers. Spread them out over the weekend. They'll review a bunch of concepts for you, okay? Yes. Yes. I would like to have a quiz next Wednesday. On 5.3, 5.4, and 5.5. So that's molarity, density and molar mass of an unknown substance, and moles and gases. Okay? So we got the word at the staff meeting last night. Cell phones next year are away at all times.
That's crazy.
All times, unless your teacher says you need to use it for X, Y, or Z. Right? So for example, I know the languages use Duolingo a lot, right? So they'd be like, take out your phone and do Duolingo.
Hold that. We're getting a hold that now.
Yeah.
Nice.
It's for teachers too. Teachers too.
It's like when alcohol got bad. It's gonna be a black market now.
Black market?
Black market.
Cool. Are we gonna have a speakeasy? Can I wear a 1920s flapper dress? So much fun. If you're really good at converting, you might do every third question here. You know what I mean? Like do as many as you need to feel like you're going to be prepared for your quiz on Wednesday. And if you want extra practice, the Mega Mole review has extra practice. On Tuesday, we're going to do a study session, so that's really so there is a video that goes over it. It's not actually a very concept here. No, it's basically all it's finding the roles that you find and then you do the questions, and then we broke up also bits. Okay. And so we can see the video.
I'm probably Yeah.